Hello everyone. We will start after 2 minutes. Okay. Um, you are able to see the screen, right?
Yes, ma'am.
Yes, ma'am.
Okay. Okay. So just we will wait for some more minute. Let other join. Then we will start from 10:08. Okay. Okay. Maybe we can start now. As you know, this is the revision session for week 7 and 8. Okay. So let us start with week 7. So, do you have any doubt related to the concept? I will cover the concept, but if you have doubt, just let me know.
Ma'am, in this session, will we do concepts and solve questions or only concepts?
Yeah, concept. I will just revise the concept. Then I will solve some question from my own. Then, if you have some doubt from this week, then you can ask. Okay. So, anything from week 7? Any doubt related to the concept?
Ma'am, first principle rule is there, right? Could you just elaborate more?
Which one? In
Uh,
week 7?
First,
Okay, just let us recall what were the content of week 7. So, if I'm writing it, if there is anything other than that, just let me remind. Okay. So, the first thing was sequence, right? So sequence means everything about sequence, and no, this was the second thing. And first, maybe we learned about function of one variable, right? Then limit of sequence. Then limit of function. These were the concept from week 7, right? Okay. So yeah, what was the doubt? Which rule you just said?
ma'am, first principle rule is there, right?
Okay, first principle root. Can you just elaborate which one? I mean, the rule. What was the rule?
Like could like f plus h minus f of a. Uh, I hope you understand now. Limit extends to
Mm-hmm. Limit extends to some number a.
yes, ma'am. F of a plus h
Yeah. F of a
minus
minus f of
f
a.
of a
Yeah.
by
Okay, it's
h.
talking about differentiability.
Yeah. This was this.
Yes, ma'am. Could you just elaborate about this?
Okay. Okay. This is from week 8 actually. So.
Ma'am, just because you are taking this topic, I have sent you a screenshot on this. Just
Okay.
open it along with it. The same topic. I want to ask you something.
Okay. Okay. Yes.
Yeah, you can. When we
all,
move to
all of
the
all
first paragraph,
yes.
when we move towards the right of a to a plus h, means a plus h is greater than a, we are moving towards right. Then the limit will be limit x tends to a plus or a minus.
Which line? Can you just mention the line?
Line from first para, third line.
First para, third line. When we move towards the right of A to A plus H, yes, the increment of F is this. Huh. So what is the problem here?
The problem is I am asking you that which limit we will apply, right hand limit or left hand limit.
This is the right. Okay. So it's actually depend. If the function is same for both right and left, then you just take simply limit extending to A. Okay, or h tending to 0, not okay. If the function varies, sometime you may see the function is different in sense of some, like in some different interval we may define some different function, right? In that case you have to use both the limit h tends to 0 plus and 0 minus, that means both the left and right.
But in the second case, they are saying something different.
No, this thing is same, like I mean this thing and this thing, these two are basically same, but like we are just here, this is the, I mean suppose for example this is your curve, okay, and suppose this is the point A, okay, this is f of A, okay. So suppose this h is a little distance, this is this much distance is h, then this is your A plus h and this is your A minus h, okay. So A plus h means f of A plus h will be this point and f of A minus h will be this point, right?
Yeah.
Okay. So you may approach from this side, you may approach from this side too, right? So the thing is here you can consider it like in so many ways. The first thing, if you can do what? Okay, you can keep this thing as same and you can use this to limit separately, okay, this is one way. And this is second way, key, you just take simply h tending to 0, that means from the positive side, and from here also h tending to 0 from the positive side. So this thing will be basically same as this thing, I mean when h tending to 0 from the negative side with this function. Am I clear with the thing? I mean, when we are using this thing, that means we are approaching to this point from the right side. That means from this angle. Okay. When we are doing this, we are approaching to the function from the left side. Okay. That means
So
this is the left hand limit and this is the right hand limit. This is one way to think about it. You can take this as your right hand limit and this as your left hand limit. Okay. In that case,
first case we can say that h tends to 0 minus.
no. In the first case, if you are taking this two separately, then we will take just h tending to 0 and we will assume it is tending to 0 from the positive side, okay. For because here we have minus of h, right? So it will be automatically tending to 0 from the negative side. I mean if h is tending to 0 from the positive side, then minus of h will be tending to 0 from the negative side, right?
Mhm.
Okay, so in this case, you don't need to take it differently. Just take simply h tending to 0 and just assume h tending to 0 from the negative side. And this is the definition for right hand side because in this case, we are tending from the right hand side of the point, right?
Mm,
And in this case, we are tending from the left hand side of the point.
mm.
And just take simply h tending to 0 and assume h tending to 0 from the positive side.
So ma'am, you just draw a straight line,
Yeah,
just a straight horizontal line.
straight horizontal line. Okay.
Mm, mm.
Yes.
Take 0 in the middle.
Yeah.
So when from where we have to approach to say that h tends to 0, and from where we have to approach to say that h tends to 0 positive, and from where is 0 negative. मतलब कि कौन सी साइड से
Okay,
हमको
okay,
अप्रोच
okay.
करना पड़ेगा
H
कि
tending to 0 from the positive side means from the positive axis of
हम्म,
x axis, positive side of x axis. That means from your right hand side. Okay. And h tending to 0 minus, that means h is tending to 0 from the negative side. That means from the negative x axis. That means your left hand side. Okay. This is negative and this is positive. Okay.
from when we are coming towards 0 from the from suppose from the negative side or -2, then we can say that h tends to 0 minus.
Yeah. So 0 minus is h is something which is like less than 0 and which is really close to 0. Okay. And 0 positive means h is something which is close to 0 and which is greater than 0. Okay.
Okay, okay.
Yeah. That means if h tending to 0 positive, that means h is somewhere here. And if h tending to 0 negative, that means h is somewhere here. Now, did you get the difference?
Yeah, yeah.
Okay. So, okay, now is it clear to you?
Yes, ma'am.
Okay. So, anybody, do you have any doubt in this portion, or is it clear to all of you?
मैम और एक बार रिपीट कीजिए ना h h टेंस टू 0 पॉजिटिव के समय h कहाँ रहेगा और माइनस के समय
H tending to 0 positive means H is greater than 0 and
हम्म,
H is close to 0. Greater than 0 and close to 0.
हम्म,
Okay.
हम्म,
And this is your x-axis. This is the origin. That means this portion is the positive x-axis, right? So
या
you have all the positive real line, real number in this side.
हम्म,
So when h is greater than 0, that means this side is greater than 0. This side is going towards the positive infinity. Okay. That means h is tending to 0 from the positive side, from the positive x-axis. Okay.
ओके
That means h will be somewhere here, which is greater than 0 and really close to 0. Okay. And h minus is
हम्म,
which is less than 0 and really close to 0. That means somewhere here,
या
which is less than 0 and close to 0. Is it fine now?
So it will always be,
नाउ
sorry,
क्लियर
I just want to clarify. So it
Mhm.
will always be close to 0 and it won't be equal to 0 in any other condition.
Yeah, when we are taking limit, that means we are not taking exactly 0. Rather than that, we are taking a point which is really close to 0. That means that point which we cannot imagine, right? Because we don't know what is the like just what is the number just immediately after 0 or immediately before 0 in the real line, right?
Okay. Okay.
So
So
we
we
are
always.
yeah, yeah. So we are taking that point which is more, which is most, which is like closest to the point 0, and 0 plus means which is greater than 0 and closest to the 0, and 0 minus means which is less than 0 and closest to the point 0. Okay.
Okay. Okay. Thank you.
Okay. Yeah. Welcome. So it's clear to all of you?
Yeah.
Okay.
मैम यू कैन गो टू द सेकंड इमेज व्हिच आई हैव सेंट
Yeah. I have. Okay, we will calculate some limit. Don't worry. Huh. Yeah. What is? Do you have any doubt in this? This is the image that I just drawn, in the previous page, right? So
Yeah.
if this is your point A, yes, if this is your point A and this is your point A minus H, so if we are doing that, A if A minus if A minus H, and when H will be tending to 0, this A minus H will be tending to A from the negative side, right?
Yes.
Because H is tending to 0, that means minus H will be tending to 0 from the negative side, right? And so A minus H will be, that means A minus H will be tending to this. When we will vary H, when H tending to 0, positive, then this number A minus H will be tending to A from the negative side, slowly, right? Is it clear?
Yes, ma'am. Yes.
Yeah. Then when A minus H will be tending to A from this side, then automatically the functional value of A minus H will be tending to F of A, right? Right?
Yes. Yes.
Because this is the point when we will vary H, we will get the point here. So we will get the functional value here. Similarly, when the point is here, the functional value will be here. So linearly, this will be tending to the point F of A, right? From the negative side. So this is because we are tending this point from the negative side. That is why we will take this as the left hand limit. Okay, because we are tending the point near A from the left hand side of the point A. Okay.
Okay, ma'am.
Yeah, and for this picture, again it's the same, right? Which when H will be tending to 0 from the positive side, then A plus H will be tending to A, right? That means in this way, this is the movement, right? Then this point will be slowly tending towards the point F of A, right? And because it is tending to the point from the right hand side, so we will say that as the right hand derivative. Okay.
A tending towards A positive.
Yes, A positive.
A plus, then A plus H will be considered as a limit.
Right hand limit.
Right
Because
hand limit.
it is tending towards A from the right hand side of A. Okay.
Okay, okay. Then H tends to which?
H tending to 0. That means from the positive side. In this portion, we will consider H tending to 0, and we don't need to write it, but we will automatically assume it as H tending to 0 from the positive side. Okay. So when we will use this portion, it will automatically conclude that H will be tending to 0 from the negative side. That is where we will always take H tending to 0 from the positive side. Okay.
Yeah, ma'am. Absolutely.
Yes, ma'am.
Got it.
Okay. So basically, if I write this thing, that means f of A minus H by H, limit H tend to 0 from the positive side. This is basically same as limit H tending to 0 from the negative side, f of A plus H minus f of A by H. Can you now imagine it? These two things are actually same.
Yes, ma'am. Now we can.
Right? So it's clear to all of you? Like we may sometime write it as this in this form, sometime we may write it in this form. So these two things are basically same. Okay, here we are taking minus H, that is why we are taking H tending to 0 from the positive side. So this thing will be automatically same as this equation. Okay, so we can use any of these two equation.
Ma'am, if we write a limit H tends to 0 minus
Yes.
f of A minus H minus f of A by H, then we can write it.
No. If you are taking 0 minus here, then you will always use plus H.
No, I am not talking about that.
Then
the first function f of a minus, if I rotate the function f of a minus h
Yes.
minus f of a by h, then
Okay.
then the limit will be reversed.
Minus f of a by h.
Hmm.
This one.
Then
Here,
h tends to 0 minus.
limit is tending to 0 minus. This one.
Can we write this?
No, this is not same because here we have h alone, right? So this h will be negative. That means in this case you will get the right limit,
Yes,
but
yes.
but in the negative version of right limit.
Yeah, we have to add minus h.
Yes.
Hmm.
Then it will be okay. Okay.
Okay. And this minus will be go before the limit, and it will be enter minus limit of the right hand limit.
Yes, yes. Then it will be the right hand limit. Okay. Is it clear? If you have any doubt, like it can be a small doubt, you can ask. You can use any of this definition. All of these are basically equivalent definitions. Okay. So it's clear for all of you?
Yes, ma'am.
Okay. Okay. So let us then start our discussion with week 7 content. So do you have any specific doubt in the theory portion?
No, ma'am. One just go through all concepts.
Okay. Okay, so if all of you are okay with the theory portion, then we will solve some problem. If all of you are agree with this, then we will solve
Come
some.
and just give brief overview of concepts and then solve questions.
The recap would be good.
Okay, okay.
Yes.
But instead of recap, we can practice question now because
No, we will practice question. And just let me recall
मतलब
it.
कि क्वेश्चन से ही कॉन्सेप्ट क्लियर होता है ना, ये तो
Yeah.
मैथमेटिक्स है.
Okay. Just we will recall the concept, just in a small form. Then we will solve some question. Okay. So what was sequence? I just taught you. Sequence is a particular type of function in which the domain is natural number, right? So we can write our sequence as fn as an, right? So this is our sequence, right? So maybe you are comfortable with the definition of sequence, right? Then we know the limit of sequence. That means as we will like calculate the limit as n tending to infinity of limit of the sequence. So it may be something finite. It may be something infinite. It may be the case that the limit doesn't exist. That means the right hand limit, I mean, sometimes you can find some 1 by 0 type of form. In that case, we will say limit doesn't exist, right? Or for the example, minus 1 power n.
Ma'am, then we have to use L'Hospital rule.
No. Limit doesn't exist mean limit doesn't exist. Okay, L'Hospital rule says that if you have the limit in this form 0 by 0 or infinity by infinity, then you can calculate the limit in this way. Okay, if limit doesn't exist, then you cannot calculate the limit using any rule. I mean, limit L'Hospital rule can calculate for the function for which limit does exist, but they are in this form so that you cannot get the actual finite limit. Sometime you may get this type of form. In this case, we will use the L'Hospital rule. Okay. Limit doesn't exist means the function is not convergent. That means for this type of function, suppose this is a sequence, right? That all of you are know. So this sequence is in going in this way, right? 1 minus 1, 1 minus 1, and so on, right? So for this type of sequence, we cannot calculate limit n tending to infinity fn, right? Because we don't know whether it will be 1 or -1. It can be anything, right? 1 or -1, right? So we don't know in this case, limit exists. I mean, what should be the exactly limit? So in this case, we will say limit doesn't exist. Okay. This is the
Ma'am,
example. Yes.
ma'am, quick question. So this example that you have shown,
Hmm.
1 minus 1, 1 minus 1, this looks like an oscillating function. Can we say
Yes.
that for all oscillating function, limit does not exist?
Yes, yes.
Okay.
For any oscillating function, limit doesn't exist. Okay.
Okay,
And
that means sin x,
ma'am,
cos
just
x, everything does not exist.
what? Which one?
It means for sin x, cos x, the limit does not exist because it always oscillates.
No.
It-
See, it's depend when at which point you are taking. I mean, when you are taking limit n tending to 0 sin x, then you know when n tending to 0, I mean the function of sin x is something like that, right? So it's oscillating, but still when n tending to 0, the function is tending to 0, right? But in this case, the function, you cannot draw the function even properly. I mean, when 1, the function is this. When this is 2, when this is 0, the function is this. When this is, the point is 1, the function is this. Then when this is 2, the function is 2. So this is not even continuous. This is completely like something oscillating.
Yeah, so got it, ma'am. But your first line that you wrote is like if we put that limit, where if the n is approaching 0, then we say yes, because sin x will approach
Yes.
0 as well.
But when we will
But
take limit n tending to infinity,
aha,
then we cannot say, right?
correct. That is what my
Because
statement.
right. This is right. So this limit doesn't exist because this can be anything between -1 to 1, right? So we don't know what is the exact point, right?
Correct.
Yeah.
One
This is
more question I have is, ma'am, in the statement you have written does not exist. Just beside that, you have written something called 0 by 0, infinity by infinity.
yes,
In those cases, L hospital rule is to be applied and found out,
yes,
right?
yes.
Does not exist means what? 1 by 0, does it mean does not exist?
Yes, 1 by 0 you can comply as doesn't exist. Yeah, 1 by 0 is not a defined number. So this is also
Okay.
case of doesn't exist.
So 0 by, okay. So 1 by 0 is the only case, right? Otherwise, 1 by infinity, we can say it exists because it will
Yeah,
approach
1
0.
by infinity is tending towards 0. So it will be, I mean, if you have 1 by n tending to infinity, then this is equals to 0. So this is a finite limit, 0.
Thank you, ma'am. That's all I had.
Yeah. So this is the case, and 1 by 0, actually it's something, I mean, you can take it as tending to infinity sometime, and you can take it as doesn't exist sometime. So in both the cases, this will be the case for a divergent sequence. Okay. So anyhow, this is not a convergent sequence if you are getting something like that. Okay.
So,
Okay.
ma'am, quick question. If the limit does not exist, can you say that the function is neither convergent nor divergent?
If limit doesn't exist, then
Mhm.
neither
Can
convergent.
you?
Okay, if
Yeah.
limit doesn't exist, then the function is divergent.
Oh, so the limit doesn't exist. The function. How, ma'am? How is the
I
function
mean,
divergent?
this is accordingly your definition. I mean, here we are using the definition. If the function is not convergent, then it is divergent. Okay, but and like in this portion of mathematics, there are several concepts, and sometimes we introduce a new definition called oscillatory sequence. So in some cases, we may say a sequence as oscillatory sequence. So we consider it particularly as oscillatory, not as convergent and not as divergent. Okay, but here in our course, we will consider the oscillatory sequences as the divergent sequence. Okay, so if it is not convergent, if limit doesn't exist, that means the sequence is not convergent, right? That means the sequence is divergent.
So when you say convergent, it basically you're saying that it's tending to zero, right?
No,
That is
no, no, no,
convergent.
no, no, no,
No,
not zero, some finite number.
some finite number. Okay,
Yeah.
but
Some
it could
finite.
also be zero, right?
Yeah, it can also be zero, no problem. Like if the limit is any finite number, then the sequence is convergent.
Okay, so if it is not convergent, then automatically you can say that
It is divergent.
It is divergent. Okay, got it. Thank you.
Yeah. Okay, the convergent sequence means the limit is any finite number. Okay, and if it is, that means the sequence is not convergent. We can write convergent sequence in short as CGT. Okay, then it is divergent. Okay, so these two are definitions of convergent and divergent sequence. That means if a sequence is convergent, that means the sequence is like the sequence has a finite limit, and if it is not convergent, that means it doesn't if it doesn't have any finite limit or limit doesn't exist, then we will say the sequence is divergent. Okay, this is the definition of convergent and divergent sequence. Okay, so just let us solve some quick example. You have one
Excuse me, ma'am.
yeah.
Ma'am, so any function which is not convergent, it is divergent.
Yes, any function, not any function of particularly sequence.
In case of functions, what will happen?
Okay, in case of function, we don't have the concept of convergent and divergent. We have the concept of convergent and divergent for sequences only. So for function, we don't have this type of concept.
Okay.
Yeah. For function, you may say the limit exists or doesn't exist. That's it. Not convergent. We will not use the word convergent and divergent in case of function, like any functions. Only for the sequences, we will use the word convergent and divergent. Okay.
Yes, ma'am.
So you know this formula, right? 1 plus n by n. This is equals to 1, right? 0, sorry. Okay, this was a formula. So just let us use limit n tending to, we will start from some very basic problem. Okay. Okay, just try to solve this sequence and let me know the answer. I will give you 2 to 3 minutes. Just solve, and you can simply unmute yourself and tell me. I will not able to see the chat. Okay, so don't write the answer in the chat box. Just unmute and tell.
Ma'am, 1 by 3.
Okay, 1 by 3. Any other answer?
1 by 3, ma'am.
Okay.
0.33.
Yes, ma'am. Same answer.
Okay.
0.33.
Okay, very good. So we know the simple way to solve this type of problem, right? We will just take n cube as common and then we will cut this, right? So this will be 2 by n, 3 plus 1 by n squared minus 6 by n cube, right? Then we will take n tending to infinity. Then this term will be going to 0. This term will be going to 0. Then we will get 1 by 3, right? This is the way to solve this type of thing, right?
Ma'am, how did you solve the first one? I missed that part. The first one, limit n
This
tends
is
to, yeah, that one.
okay. This is a particular formula. I didn't solve it.
Okay. Okay.
You can solve it using the L'Hopital rule. This is a formula.
Okay, it's a formula. Okay.
Yeah. So this is the example, first example, And all of you are like comfortable with this type of examples, right?
Yes, ma'am.
Yes, ma'am.
Okay. Okay. So second example, suppose you have your an equals to e power some 2n plus n to the power 4 and e power some n. Okay. 4n suppose. Then you have to calculate the limit. Okay. So what will be the limit in this type of case?
Zero.
Okay, 0. Any other answers? Any other answers?
1.
Ma'am, limit n tends to 0. We have to
And
find.
no. When we are saying ki we are calculating the limit of a sequence, we will always take as n tending to infinity.
Okay.
To calculate limit of a sequence, okay? Always take n tending to infinity.
Limit is
Yeah, I
1.
also got a 0.
Okay. Okay. Let us solve it. Okay. So what should be your first step? Just one of you can unmute yourself and just tell me what should be the first step here for this type of thing.
Using L'Hopital rule.
Okay, so you are using L'Hopital rule here.
Yeah. I approached it in a different way.
Power 4n.
Just,
Okay.
divided by all e by 2n.
Yeah, right. So
Yes, I have done this. E by 2n.
Yeah, you can solve this using L'Hopital rule, but I will recommend you not to use L'Hopital rule when you have exponential function. Okay, then you will not get, like, it will not be vanishing in some after some step, right? So just take the factor as common. You can take, so we will take e power 2n as common, then we will get n power 4 by e power 2n, right? This is the step you did, right? Then we
Yeah,
will
that's right,
cancel
ma'am.
them out. So we will get e power 2n then, right?
Correct.
Yeah. N power 4 e power 2n by e power 2n, right? Then we can take the, like using the quotient rule, we can take the limit as this, right? N tending to infinity, n power 4 e power 2n by limit n tending to infinity e power 2n, right? And we know that the growth of exponential function is greater than the growth of any polynomial function, right? That means exponential function is always greater than n power 4, right? That means this n power 4 by e power 2n will be less than 1, right? For any n. I mean, after some n. I mean, eventually this is true, right? So when we will take n tending to infinity, this limit will be tending to 0. Right?
Ma'am, what is e power infinity?
E power infinity is infinity. That means when extending to infinity, exponential function will be tending to infinity also, right?
Okay, ma'am.
Yeah, so e power infinity is infinity, but we will consider this function. This function is n power 4 by e power 2n, right? And we know that the exponential function is the like most fast growing function, right? We had a portion in your lecture that we were comparing the exponential function and polynomial functions, right? And in this portion, we have seen that the exponential function is the most fast growing function from all the polynomials, right? So this portion, this function will be less than 0. That means this is something really small. I mean, this is tending to 0. When we will tending n towards the point infinity, then we will find the function as tending to 0. So we will then find 1 plus 0 by infinity, right?
Ma'am, is a power x is a polynomial or exponential?
This is an exponential function. But x power something a is, this is exponential function and this is polynomial function. Okay. Is it clear?
Madam, here what
Yeah.
you are trying to say, so n by 4 is a number and divided by the infinity, which means it's a very large number. So the division will be almost approximately 0, right?
Yes, yes, yes.
Understood. Okay.
Yeah. So if we had this case, I mean this, then this limit should be tending to infinity, okay? Because this is the larger function.
I understood. Okay.
Yeah.
Ma'am,
Yes.
ma'am, can you explain the n by 4 upon e by 2 and that part again?
Yeah, sure. So if we have some fx by gx, suppose, okay, and suppose when n tending to infinity, both the function are tending to infinity, okay. So in that case, how we can uh, calculate this function? The first thing is you can use the L'Hopital rule to calculate this function. This is the most easy way. You are also comfortable with it, right? But to use the L'Hopital rule, you have to use 3 to 4 step at least for this function, right? You will just differentiate this function and then you can calculate the limit, okay. But if in this case, if gx is greater than fx, that means if gx is most fast growing function then fx after some n, then this limit will be tending to 0, okay. And if gs is less than x, if then this limit will be tending to infinity. So this is something analytical way to solve this in one step. You can just analyze this type of thing and do this, and the most safest way is you can use the L'Hopital rule, okay. So if you have the limit n tending to infinity, n power 4 e power 2n, this is in infinity by infinity form, right? So you can use the L'Hopital rule, you can derivative this function, then you will find ultimately 1 over infinity, right? Because this function will be something vanishing after fourth term, right? This will be some constant and this function will be same. Exponential
Yes,
function
ma'am.
will never vanish, right? So we will get 1 over infinity type of thing. So this will be ultimately tending to 0. Okay. So is it clear?
Yes, ma'am.
Yes, ma'am, it is clear.
Okay. Okay. So the limit is 0. You can calculate. Okay. Okay. Let us do one more example. Suppose you have the function as n power 4 okay. Just calculate the limit for this type of function. Just let me know what is the answer. Use the same type of logic for this function also, okay? Sorry, this will be n power 4, okay? Just note the correction. This will be n power 4.
Ma'am, is it 1 by 2?
Okay, 1 by 2 is one answer. Any other answers?
Ma'am, 2 minutes.
Okay, okay, I'm waiting.
I'm 1/2.
Okay.
Yeah, I'm also getting 1/2.
1/2.
Ma'am,
Yes, ma'am, I am also getting 1/2.
Okay. Okay. Very good. So
ma'am, I am also getting same.
okay. Okay. So 1/2 is the answer. Okay. It's really good to see all of you can solve all the sequences right now. It's really good to see. So you will get this type of problem in the exams also. Okay. Once you can solve this type of thing here, you can also solve in the exam.
I have one doubt, madam.
Yes.
See here, you not mentioned the limit, but then others are the easily calculated. Okay, I understand they divided by the higher degree number with all numerator and denominator. So if you're not providing the limit, how we can estimate, madam? Actually,
Okay.
what is the thing?
Okay. The thing is, you will be providing the limit in the exam, and
Okay.
if it is not the case, if like when someone says you to find the limit of a sequence, you will always consider as n tending to infinity. Okay, this will be in the exam, this will be provided in the exam, but still, if just for sake, if there is nothing mentioned there, they just may ask you to calculate the limit of the sequence. You will always take the limit as n tending to infinity for the sequences, okay, not for the function.
Okay, in this case, here cos n is available. So what is the value they will substitute? How they are told actually?
Yeah,
How they
I
are
will.
called?
Yes, I will solve this problem step by step. Just note this thing, okay?
Thank you, madam. Thank you.
Yeah. Okay, you just note this thing. When we will be when in the exam, this will be mentioned in maximum cases, but if some case, suppose they have asked you to calculate the limit, you will take the limit n tending to infinity automatically. Okay, so this is the single case for sequences, but not for function. If there is a function, they will particularly mention the particular point at which you have to calculate the limit. Okay, this is a note, you just take it. Okay.
Ma'am, I have a question. The next question basically, so practice assignment 7, question number 5.
Okay.
So that is, I mean, I was able to get that answer, but I have like a question which I was not able to think through.
Okay. I will go to the question, but let us first solve this one. Then we will go to your doubt. Okay.
Okay. That's the same, like it's based on the same pattern.
Okay. I will go to your doubt. Just let us first solve this one. Okay. So as yes.
If you came by any plan, so you complete that your whatever you planned, madam. Then the end of the session, the whatever the people doubts you can clear. So
yes.
then what you planned,
Yeah. I have some selected problem which are really important from the exam point of view too. So I will solve the problem first. I will just recover your definitions, concept, and then solve the problem. Then after this, I will pick your doubts too. Okay. Okay. So yeah. Okay. So as you know, we in this type of case, we always take the highest power as common, then we will cancel this. So with following the rule, we will get this thing, right? Cos n by n power 4 2 plus ln of n by n power 4 plus 1, right? This is the next step. It's clear to all of you, right? You are able to follow this. Now in the next step, we will just use the quotient rule and we will divide the limit, right? So we will get 1 minus limit n tending to infinity 3 by n squared plus sorry, right? 1 over n, sorry. This step is also clear to all of you, right? So clearly this limit will be going to 0, right? This will be also going to 0 because cos x is something finite, right? We know the boundary of cos x. It is between -1 to +1, right? If there was some function which is not bounded, then we have to calculate whether this is a first growing function then n power 4 or not. Like we have to apply the L'Hopital rule basically, right? And if we have some bounded function and then this type of thing here, then we will take this. That means we will get anyways what n doesn't matter. We will get some finite number by infinity, right? This will be tending to 0, right? That is what this whole limit will be tending to 0. Okay, is it clear?
Yeah, ma'am.
Yeah.
If we take, ma'am, sin n or tan n, then
Okay, so if you take sin n, then sin n is also again a bounded function, right? Right? But
yeah,
if you take tan n, you know that when n tending to infinity, tan n is not a bounded function, right?
yes.
So in that case, you cannot apply this, but you can apply your L'Hopital rule. Then you can again calculate the limit if it is possible, if the limit exists.
Ma'am,
Yeah.
can you apply the L'Hopital rule and solve one question?
Yes, I will apply the L'Hopital rule and solve the question when we will be solving the function, like limit of a function. So I will definitely apply the L'Hopital rule. So in this case also, I mean, are you getting my point here? If you have something bounded function over some n power some a and limit n tending to infinity, then it will be tending to 0, right? Because this will be, anyways, this will be something finite when n is tending to infinity. Doesn't matter what is the number, but this will be something finite, right? And this will be tending towards infinity, right?
Yeah, ma'am, if you say, as you say, for the tan, we need to apply the L'Hopital rule.
Yes.
Only for the particular section alone we can apply, or for the entire series we have to apply the L'Hopital rule, ma'am?
No. For the particular section, because
Okay.
for the particular section, we only need the L'Hopital rule, right?
Okay.
Yeah. So when we are using the quotient rule, that means we are now all these limits are separate thing. Okay, so we will calculate all the limits separately. So if you are trying to using the L'Hopital rule, so you will use the L'Hopital rule separately for this particular limit. Okay.
Okay.
Yeah. Okay. So again, this will be going to 0, right? Using the L'Hopital rule, right? And this will be going to 0 using the, this is normal, 1 over infinity, right? So we will get 1 over 2. Okay, is it clear?
Yes, ma'am, it's clear.
Yes, ma'am.
Okay. So it's fine for all of you, right? Then we can move to the next question.
Yes, ma'am.
Okay.
Yes.
Okay. Then we can come to the limit of function. Okay. So whenever we are talking about limit of a function, we will mention a point a, x equals to a, and we will calculate the limit at x equals to a. Okay, and we denote it as x tending to a, the function f of x, right? So if this is something finite, it can be 0, it can be non-zero, but any finite real number, then we will be saying that this will imply that limit exists. If the limit is not finite, then limit doesn't exist. Okay. Okay. And again, we have the concept limit x tending to a plus fx. that means the right hand limit RHL, and that means we will be tending to the point A towards from the right hand side of A, right? That means from the right hand side of the x-axis, right?
Yes, ma'am.
Yeah. And limit extending to A minus fx, this is our left hand limit, right? If both the limits, suppose this is, if RHL equal to LHL, then we will imply that limit exists, right?
Yes, ma'am.
Yes, ma'am.
But if not, that means if RHL is not equals to LHL, or any of the limits suppose doesn't exist, and one limit exists and one doesn't exist, or if they are not equal, then we will immediately imply limit doesn't exist, right?
Yes, ma'am.
Yeah. These things we already know very well, right?
Ma'am, in this one, we have stated that if it is not finite, then the limit doesn't exist.
Yes.
So
if it is something infinite, then we will say limit doesn't exist. Okay.
So in the sequence, we have just seen that if the limit set is infinite, then we could have something that it's reaching to.
Yeah, but this point is infinite, right? I mean infinity. In that case, we were saying it the sequence is a divergent sequence, right? Here
Yes,
we will
ma'am.
say limit doesn't exist. Okay.
Okay.
Sometimes we say like when the limit is tending to infinity, sometimes we say that it is the limit is infinity, or sometimes we say that limit doesn't exist. So here let's not create any type of ambiguity, just take it simply limit doesn't exist when it is going towards infinity. Okay.
Okay, ma'am.
Yeah. Okay. Okay. So just let us solve some limit intending to 0. Okay. This is your one of your formula, right? So how to solve this type of thing? We should mention one rule, sandwich theorem. So you know about the sandwich theorem, right? So if we have 3 sequences,
Ma'am, it's not sine inverse x, ma'am. It's sine of x.
No, sine, it is it's sine inverse x. I mean it.
So ma'am, we can write it as cosec x.
This is sine inverse x. So you cannot write it as, I mean, cosec x, I mean directly. So you can
It's
again
1 by x sin x.
Yeah, you can do that expansion. Again, this is okay. So you don't know the derivative of sine inverse x. You had the formula, right?
प्रधानमंत्री वाला खाली पेट वाला
Yes,
पत्ता है ना,
ma'am.
वो अच्छे से काम नहीं.
What was that? Okay, so you have the formula for limit extending to 0 sine, the derivative formula for sine inverse x, right?
Yes, ma'am. 1 upon under root 1 minus x square.
Yes, that's what you need to apply. I mean, you will get this 0 by 0 form, right? Sine inverse 0 is 0, right? So this will be again in 0 by 0 form. Then apply the L'Hopital rule.
Ma'am, the answer is 1.
Yeah, right. The answer is 1. So this is in 0 by 0 form. So we will use the L'Hopital rule. So we will get this thing, right?
Madam, I got one doubt.
Yeah.
So sine 0, we know the 0, but sine inverse of 0, how, madam? I don't know that concept.
Sine inverse of 0 means, I mean,
on which degree value of sine x is 0.
Okay. So
okay, in this case, we can consider as a 1 by sine x.
No. This is not like in that sense. Sine inverse means inverse of a function. This is inverse of sine function. Okay, this is not 1 over sine x.
Actually, sine 90 is 1, sine 0 is 0, so that we can understand. But sine inverse of
Yeah, sine is 0, no? That is what we have. So if we can use the inverse function both side, right? Sine inverse x, sine inverse of sine of 0 equals to sine inverse of 0, right? And we know that this multiplication is the identity function, right?
Okay.
So this will be identity of 0, right? Which is 0.
Okay, in this case, same value only it will come. It's either inverse or normal.
For the particular point 0, it is same, but not for all values. I mean, sine inverse of pi is 1.
Yeah, understood. So based on the degree, it will come.
Yeah.
Yeah,
Pi by
I
2
understood.
is 1,
Okay.
right? Then we can do the... Okay?
So in this case, sine inverse of pi by 2 and sine pi by 2 both are same value only, right?
No. Sine pi by 2 is 1 and sine inverse of pi by 2. Sine inverse of pi by 2 is we have to calculate it. But sine inverse of 1 is pi by 2.
Understood. Okay, understood.
Okay.
Okay, noted. Thank you.
Yeah. So now if we just put 0, we will get 1. Okay. So just use the L'Hopital rule in this type of problem. Okay.
Okay.
Yeah. So you know about the sandwich rule, right? A, B, C. If you have the 3 sequences, such that.
Ma'am, one more question. That derivative of sine inverse x 1 upon root of 1 minus x square, is that something? I mean, I'm not able to derive it. Is that something that needs to be memorized?
Yes, this is a formula. I mean, you can calculate this, but this is a lengthy process to calculate this. I mean, this derivative. Better if you can remember it as formula.
Okay. So it needs to be memorized. Thank you.
What will be the value for cos inverse of x by x now?
Cos inverse of x by x.
Yeah.
I mean, when tending to 0.
Yes.
Then similarly,
derivative rule, the formula is there, no? So similarly for cos also there should be some formula, right? Just to note it down.
No. But when it is cos inverse of 0, but cos inverse of 0 is not equals to 0, na? So we will not get the 0 by 0 form, right? This is.
Ma'am, he's asking the derivative of cos inverse of x.
Yes.
Okay. So if this is the limit, then you cannot calculate the limit, but you can calculate the cos inverse. Probably this is minus 1 over 1 minus x square. If I'm not.
Okay.
Yeah, you can check it. You can just.
Okay.
Yes, ma'am, it is correct.
Yeah. Okay. So this type of question you may have, and using this type of thing, you may have some logical questions. So just for example, you can take one limit. Suppose we can define a function, some x plus 2b is equals to minus 1. Okay, so suppose we have this type of function, and we have the hint that f is continuous at 1 and minus 1. Okay, then you have to calculate a and b, the value for a and b. Okay, so we have already solved this type of question earlier, right? So you just Okay, sorry. Not continuous, take it limit exist. Okay. Suppose limit exists at -1 and +1, then you have to calculate the value of A and B. So you know the definition, just apply the definition, then we will find some equations, right? Then we solving the equation, we can find the value. Is the question clear?
Yes, ma'am, it is clear.
Okay, very good. Then just solve the question, and yeah, you can let me know the answer in the just unmute yourself and tell me the answer. Okay.
Ma'am, value of A is -3 and value of B is 2.
Same, ma'am. Yeah, that's the even I'm getting the same answer.
Okay, very good. So, what about others?
My B is 2 and A is -3, right? Yeah, that's.
This is same, right? Okay, very good. So let us solve this together. Okay. So we have that the limit exists at the point -1 and 1. Okay. That means by the definition we can say a limit extending to 1 plus fx is same as
limit extends to 1 minus fx.
Yes, very good. Right. Then we will simply write the function and calculate the limit, right? So 1
Yes,
plus
ma'am.
means which one we will take? This one, right? 1. So, and 1 minus means we will take this function, right? So we can directly put the limit. So we will get 1 equals to 2 plus A plus B, right? So this will imply A plus B will be equals to 1 minus 1, right?
Yes, ma'am.
Yeah. And secondly, we have the limit exit -1, right? So again, we will use the same logic, right? Extending to -1 negative fx, right? So first -1 negative means we will take this function. So this will be ax plus 2b, right? And this function will be 2x squared plus ax plus b. Then we will simply put -1, like we will simply calculate the limit. So we will get -a plus 2b equals 2 minus a plus b, right? So we can cancel them out. Then we will get b equals 2, right? And then a will be equals to -3. Okay.
Ma'am, sorry, ma'am, little bit slower, ma'am. The first one you mentioned, right, ma'am? Limit 1 plus limit extends to 1 plus. You substituted it for the this is equal to 1, is it, ma'am? Limit extends to 1 plus. After that, what, ma'am?
Limit extending to 1 minus. Then we will take this function. 1 minus means it is tending to 1 from the negative side, right? And when
Okay.
x is in this interval, we know the function is this, right? So
Yes,
in this interval, we can get the value of the function as in this form, right? 2x squared plus ax plus b. That is why we took the function. Okay.
So you are equating that to x1 plus, which is equal to 1. That is, if x is greater than 1, I have to pick the value 1. So 1 equal to 2 plus, you are applying 1 there. So 2 plus a plus 2 plus a plus b. So from there you have got a plus b, ma'am. Then here, ma'am, the below section, what you have done?
Below section we did the same, right? Because again the limit exists at -1. Okay. So we will just use the definition of limit at -1, and then again we can get one more equation using a and b. Okay. Then using these two equation we can solve the value for a and b. Okay.
Okay, ma'am. So 1 we have to take for 1 plus, and then for the minus 1 you have to take the 2 thing. Okay.
Yes. Okay. So this type of thing is clear, right?
Yes, ma'am, clear.
Okay, very good. So this was in my mind from your week 7. Now we can move to week 8. We will just recall the contents. So we learned about limit and continuity for a function of one variable, right?
Ma'am, a quick thing though. ये limit में, like, what happens to the limit when you have, like, let's say if your f of a tends to limit a, then what happens if you have f of a into g of a, where g of a is tending to limit b? So things like that, I don't think that is discussed. So I mean, towards the end of the session we can discuss it, but there are some questions around that.
No. You just ask me the thing. I will explain. Just repeat your doubt.
So basically, what I'm saying is, let's say if f of a limit n tends to a, f of a is pointing to a, and limit n tends to b, then f of b is tending to c. Then what will be the limit of f of a into g of a? Like that questions.
Okay. So
that,
I mean, g of a is suppose b, this is suppose c. Okay.
correct, ma'am.
Then you are saying the limit of fx gx, right?
Correct.
Okay. So in this type of case, we will apply our multiplication rule, which is simply the fx limit n tending to infinity gx. Okay. Then this limit is b and this limit is c, right? So this will be bc.
bc. Okay. All right, ma'am. Thank you.
Yeah. But this type of case, we had the formula that limit n tending to infinity an plus bn is equals to limit an plus limit bn, and multiplication, right? So for the quotient rule also, so limit an by bn equals to limit an by limit bn, provided that this limit is not equals to 0. So we had this type of formulas, right? So in this type of cases, you just need to apply this formulas. Okay. And one more formula, sandwich rule. I was about to mention it, but I just forgot. So that means if you have 3 sequences, an, bn and cn, such that they have some inequality, bn less than cn, and we have that an is tending to l, cn is tending to l, then we can imply that bn will be again tending to l. Okay, so this was the sandwich rule. You do remember the sandwich rule, right? This was sandwich rule, correct? So using the sandwich rule also, we can calculate some limit. That just for example, your sin x by x. Okay, this type of limit we can calculate. Or suppose minus 1 power n by n. Okay, we know that limit is tending to 0, but how can we prove? Right? So this is basically minus 1 power n over n. This limit is less than 1 over n, and this is greater than minus 1 over n, right? So we can take this sequence as an, this sequence as bn, and this sequence as cn. And both the sequences tending to 0 when n tending to infinity, right? So we can imply that this bn will be tending to 0. Okay, is that clear?
Yes, ma'am.
Ma'am, for the previous question, can you tell me how you got the value of B and A? Just the calculation part.
This one?
The previous question.
This one? Okay. This.
No, A and B. Yeah. The last part. How do you get the value of B and A?
Minus A and minus A will be cancelled out, right?
But it's 2 minus A, right?
Yeah. So what's the problem?
Okay, so it'll be 2, right?
Yeah, so we have 2b equals 2 plus b, na? Then
okay, 2 plus b. Okay, okay. Okay, thank you.
Yeah.
Question, say I have one small doubt, madam. See, in this above previous one, madam. This one, so the limit, see, one side, the positive and negative we are comparing, that is, I can understand. And here, that the equation you selected, no, that for example, n minus, for n tends to, where is n tends to 1 plus, and n tends to 1 minus. So this one, how you are selecting, madam, actually? So earlier one you selected compared minus and right. So yeah. Here.
Okay. So just this is a simple logic. Okay, when we are tending, like when x tending to 1 plus, that means x is tending to 1 from the positive side, right? That means this portion, right?
Yes, correct, madam.
So we will take this function, the corresponding function. Okay. When x is tending to 1 minus, that is from the negative side of 1. So we can find the interval where x is like near, x can be something closer to 1 and less than 1. So this is the interval, right? And we will take the corresponding function. Similarly for minus 1, because we are tending to minus 1 plus, so in this interval we can take see that x can be something which is close to minus 1 and greater than minus 1, right? So we will take the corresponding function. Similarly, when x is tending to minus 1 from the negative side, so we will take the corresponding function. Okay.
Okay. So for that only the combination you are taking the middle term, and so one is comparing with direct limit substitution. Another one approaching, and one.
Yes. So when this type of question, I mean, you first step is you have to apply the definition. That means the left hand limit and right hand limit will be same. Okay. And while selecting the function, first you just select the interval for x. Okay. And when you are taking x tending to some a positive or negative, so it will be the interval will be mentioned in the function, right? So you just first have to select the interval that for which interval it is possible to take x towards a from the positive or negative side. Okay, so first select the interval, then take the corresponding function. Okay,
madam. Thank you.
Yeah. So
the sandwich rule, can you explain once more? And I would like to know, like, what kind of problems we can get for the sandwich rule.
Sure. So sandwich rules means, I mean, if you have 3 sequences with this inequality, okay, for each n actually, okay, for each n, okay, if you have this inequality, and if you have provided that this limit of a and limit of c are basically same, I mean both the sequences a and c is tending to L, then you can imply that the limit of b will be L. That means the sequence which is in the middle, this will be tending to the same limit. Okay, and we can apply this in this type of problem. So this sequence is clearly less than this sequence for all the n, right? Less equals to, right? And again, this is greater equals to this sequence for oral, right? And both the sequences are tending to 0 when n tending to infinity, right?
Right.
So the middle portion, the middle sequence, which is in the middle, the sequence Bn, this will be again tending to 0 using the sandwich rule. Okay.
Okay, got it. So it's basically you're just deriving by way of that equality that if sequence A is tending to 0 and sequence B is tending to 0, then the sequence C is also tending to 0.
Yes. Okay. So you just, this is a simple proof. I mean, when we have this n less than Bn less than Cn, once we take the limit, then we will get the equality, right? I mean, greater equals to or less equals to, right? Limit Cn, right? So this is L. So we have L less equals to limit Bn less equals to L, right? So from
Right.
here we can imply that limit Bn will be equals to L, right? Because this is a number which is greater equals to L and less equals to N. So only we have one possibility, that the number is itself equals to L, right?
Got it.
Yeah. Okay. So is it clear up to now, whatever I just covered?
Yes, ma'am.
Okay. So I guess then it's clear to all of you, and you just try to practice this type of problem, okay? That I just covered. This type of problems are only important, okay? So we know what is the limit. Then we know what is continuity of a function, right? So just roughly speaking, if we can draw a function just with a single drag of our pencils, then we will say the function is continuous. And by the definition, first condition is limit should exist. So then limit extending to some a, f of x will be equals to f of x if the function is continuous at the point a, right? Right? And continuity means continuous at a, it will automatically imply that limit exists at a, right? This we know, right? Because in the case of limit, we just needed the limit to be something finite, right? Like limit extending to a, f of a, if it was something finite, then we would say that the function, the limit exists for the function, right? And for the continuity, this L, I mean that finite number should be particularly the functional value of the point, right? This
So,
is the,
ma'am,
yes.
continuity and continuous are two separate terms with two separate meanings?
No. Like these are two separate terms, but not separate meaning. I mean, the function is continuous at a. That means continuity means this is, we are talking about the behavior, okay? And continuous means we are saying that the function is continuous at that.
Okay.
These are same, like not something different. Okay.
Yeah, because there is one confusion. There is confusion that I have with this continuity is somewhere I read that for the function to be defined as continuity, the differentiation has to exist at that point. The point has to be differentiable. I don't know if that understanding is wrong, but maybe we'll cover.
Continuity, okay. Continuity of differentiation.
No. I mean, when do we say that a function is when do we say that a function is continuous? What are the points that we have to consider saying that this function is continuous if it satisfies so and so condition?
This
So can you
definition.
elaborate?
This definition.
Only whether if the limit exists coming from the left and the right, that means it is a continuous. That's the only definition of it.
Yeah, I mean, this is not the definition. This is a if and only if continuous, but you can take this as definition actually. So from here we will take this as definition. So if this limit holds, this definition holds, then we will say the function is continuous. Okay.
Okay.
Ma'am,
So
if the function is differentiable,
Uh-huh.
right? Can it be automatically called as continuous?
Yes. Differentiability is something more than continuous. So differentiability imply continuity.
Okay. So if it's differentiable, that means basically you can take the derivative.
Yes.
And if that derivative exists, that means the function is basically differentiable and also continuous, correct?
Yes. If a function is differentiable, it is automatically continuous.
Okay, thank you.
Yeah.
I think Madhav has given a very good point. Thank you, Madhav, for that.
Yes. And if a function is continuous, that means limit exists. Okay. So this is the definition. It's enough to just remind the definition. And differentiability was the definition of differentiability, we just discussed about it, right? We will take this, let us take this definition. So if this limit exists finitely, then we will say the function is differentiable, right? And we will denote it as f dash a. Okay, and this is called slope pattern. Okay.
Yes, ma'am.
Yeah, and we know about tangent. Some like tangent is just the straight line at some point. That means this tangent will touch the curve at that point, right? So suppose this is the point f of a, and this is the point a in the x-axis. So this line is tangent. Okay, t is tangent to the curve c, which touches the curve at the point f of a. Okay, and this theta is called sorry, actually this is not the slope, this is the derivative. Okay, sorry, this is derivative. This theta is called slope, and m is equals to tan theta, and the m is actually your f dash a. Okay, so this is mathematically, I mean, once you have tangent, then you will get the angle of the tangent with the positive x-axis. This angle is called slope of the tangent, and this is basically equals to m. Okay, and the m is, that means tan theta is nothing but your f dash a. Okay, and then we know the equation of tangent, which is simply y dash equals to a minus a f dash a plus f of a, right? This is the equation of tangent, and this is the linear approximation of the function f at, not at a, near a, right? These things you already know, right? Maybe we don't need to cover it in detail. So is it fine, or if you have any doubt, you can just ask.
And this linear approximation is quite, I mean, it was not the thing that I just grasped in the first part. So can we have a little more precise?
Yeah. Okay. So the equation for the linear approximation is same as the equation of tangent. Okay, linear approximation is like if you have a curve, and suppose you don't know the equation of a curve, but you want to know the nature of the curve near some point. So using the linear approximation, you can conclude something about the nature of the curve near the point. I mean, once you have the point a, this is the tangent line, right? And if you just see the like the closed interval or the neighborhood of a, so in this portion the curve and the linear approximation, that means the tangent, are almost same, right?
Ma'am, I didn't.
I mean, let us just zoom this portion. We have the curve, this, okay, and this is the tangent, okay.
Yes, ma'am.
And this is the point A. Okay, so if we consider this portion of the curve, in this portion, the tangent and the curve are overlapping, right? I mean, they are basically same in this portion, right?
Yes, ma'am.
Yes, ma'am.
At least they are almost same in this portion, right? If just zoom out this portion, okay? So that means, so this is a curve, right? So this will have some different equation, but the tangent is a line, right? Which is approximately same near the point A, okay? So basically, if we draw the tangent, we are approximating the curve with some line. That is why we are saying it as linear approximation of the curve near the point A. Okay. Because we don't know the equation of the curve, but we can just find some straight line which is same in this portion. In this portion, the curve and the line are same. Okay, so this is the linear approximation of the curve near the point A. This is called the linear approximation. Okay.
Okay, the curve, the line which is touching the curve, the point around the touching point, we are taking those points to predict the whole line for the particular curve.
Yes, yes.
Okay.
Okay. So is it clear to all of you?
Yeah, ma'am.
Yes, ma'am, it is clear.
Okay, okay. So this is why we called it linear approximation, and whenever we will be talking about linear approximation, you will just take this equation. Okay, this is the equation for tangent and this is the equation for linear approximation. Okay, and one more thing we know, if a function f is differentiable, if and only if tangent exists at some point A, if and only if linear approximation exists at some point A. Okay. So once a function is differentiable at some point, we can draw the tangent, and the tangent is itself linear approximation. And once we can draw the tangent at some point of the curve, then we can directly conclude that the tangent, the function is differentiable at the point. Okay.
Madam, I go one point.
One by one, please.
Okay, you continue, sir. You continue, sir. Sorry.
No, go ahead after you.
Okay, I'll continue. Madam, now for the tangent having a slope 0 means, so it is continuous or differentiable. How is the meaning actually?
Okay, so slope 0 means, I mean, whenever we are saying slope 0, that means slope exists, right? If slope exists, that means the function is differentiable. Okay.
If slope 0
Slope
means
0 means this theta is equals to 0.
Okay.
That means we will get parallel lines.
Parallel lines, but it is differentiable only.
Yes, it is differentiable.
It's differentiable, right?
Tan 0 is defined, right? So the value of f dash 0 is this.
Okay, okay.
Okay.
And we can tell that function continues also based on that left and right limit combination.
Yes. Because differentiability automatically will imply the function is continuous, right?
Okay.
Thank you. First equation, y equal to x minus a of f dash of a plus f of a. So I can relate those f a and f dash a and all. This x value is what, ma'am?
X minus a.
Yeah, yes, ma'am. So in that x is what?
X is the variable. I mean, we have the function fx, right? X is variable.
Okay, but we have function f of a only here. Then this, what is the difference between f of x?
No, x is the variable. I mean, this y means this is basically y of x. I mean, this is a function of x. I mean, we are defining a function, right? Okay. So we need a variable to define a function, right?
Okay.
So x is the variable here.
Okay.
Any other doubt?
Ma'am, I have sent you 2 questions in chat box. Could you once see, ma'am?
I cannot see your question. Can you?
I'll send it again.
Are we moving on to the doubt clarification now, or we are still covering?
No, I will clear the doubt, but I have 2 or 3 questions maybe. So I will solve the questions too. Just I will take this doubt, then I will solve. Okay, you just share the question. Let us solve 2 questions. Then we will like pick your doubts one by one. Okay.
Okay, ma'am, no problem.
Yeah. So just suppose we have a general function, some general polynomial a naught plus a1x plus a2x squared. Okay. And suppose you need to calculate f dash 1 plus f dash minus 1 plus f dash 0. Okay. So you just have to tell me the what will be the value of this.
So is that a1x plus a1x square? Is that what you have? A0 plus a1x plus
Sorry, this will be a2. Yeah, thank you.
a2.
Ma'am, 3 times A1.
Yes, ma'am, 3A1.
Okay.
Yes, ma'am, 3A1.
Okay. So all of you are getting same. So I guess this is the right answer. So just let us solve. So we will first solve f dash x, right? Which will be a1 plus 2a2x, right? Then we will calculate f dash 0, which is a1, f dash 1, which is a1 plus 2a2, and f dash minus 1, which is a1 minus 2a2, right? So we will just add them. So we will get 3a1. Yeah, this is correct. Okay. Okay. So suppose we have a function f. This is suppose differentiable. Okay. Okay. And just take differentiable everywhere. Okay. Okay. So we'll just take some f dash 0 equals 1 and f of 0 equals okay, just minus 2, suppose. And suppose if we have y equals ax plus b, this is the tangent. Okay. Tangent at x plus 0. Then you have to calculate the value of a cube plus 9b cube. Question is clear, right?
Yes, ma'am.
Okay. Yes, just solve this.
Ma'am, is it 9 times B cube?
Okay, 9 times?
No. I'm asking, is it 9 times B
Yeah,
cube?
yeah, 9 times b cube.
Minus 80, ma'am, I'm getting.
Minus 80.
Yes.
Okay. Any other answers?
I'm calculating.
Okay, I'm waiting. Just calculate.
Ma'am, can you explain the question again?
Okay, so we have the function f, which is differentiable everywhere, it's given. Okay, and we have these two values, and we have given this is the equation of tangent of the function at the point 0, and you have to calculate the value a cube plus 9 times b cube.
Getting minus 70.
Minus 70.
71.
Okay.
Yes, ma'am. Please, I have done that mistake. Even my answer is 71.
Okay. So all of you are getting minus 71. And let us just solve. Okay. So we know the equation of tangent is. What will be the equation of tangent? Just guide me.
Equation of tangent.
Ma'am, you first you suppose f of x equal to y equal to this function. Then you have to find f dash x.
Yes. So if we want to calculate the equation of tangent at the point 0, so what is the rule? This is the rule, right?
Yeah.
And we have given this is equals to ax plus b, na? Right? So basically we have x plus minus 2 equals ax plus b, right? Right? We will just put the values. F dash 0 is 1 and f of 0 is minus 2. Okay, so we will just compare the coefficient. So here we have 1, here we have a. So a equals 1 and b equals minus 2, right? So a cube plus 9b cube then will be 1 cube plus 9 into minus 2 cube. That means 1 plus 9 into minus 8, right? Right? Okay, so this is basically minus 17. Okay, so this type of question we can solve in this way. Okay, so okay, do you have any doubt what I just covered up to now?
No, ma'am, no doubt.
Okay. Okay, that's all from my side.
Ma'am, I have sent you again the chart.
Yes. Now
Please
I
could you
will
solve?
put the doubts. Yeah, sure. Okay, yeah, which one?
Both of them, ma'am.
Okay, so in the first question you have f of 2 equals 10 and f dash 2 equals 4, then you have to calculate this value. Okay. Okay, so so if we just put 2 here, just put 2, so we will get 2 into f of 2 means 10 minus 2 into f of 2 means 10, right? That means 0. And this is 0. So
Yes,
we
ma'am.
will get 0 by 0 form, right? So we
Yes,
will
ma'am.
use the L'Hopital rule, right? So in this next line, we can write it as if dash, sorry, f of 2 is constant, and for x we will get 1 minus 2 into f dash x, okay? And here we will get 1, okay? Then we will simply put the value. So we will get f of 2 minus 2 into f dash 2, right? So f of 2 is 10, then 2 into 4. So this will be 10 minus 8, right? Which is 2. Okay?
Okay, ma'am. Ma'am, I thought something else, ma'am. I thought we have to put some first principle rule is there, right? I thought we have to do something.
Okay. No. If when you are getting the indeterminate form, don't think about anything. Just simply apply the L'Hopital rule. Okay? Is it clear?
Yes, ma'am. It's clear.
Okay. Very good. And the next problem. So what is in the next problem? Extending to is it the same if, or if is given there or not? Okay, f of 9
It's given. I
f
think
is,
this is also can be done by a hospital.
yeah. So f of 9 is 9 given here. So we will get 2 into 3 minus 3 by 3 minus 3, right? So again it's 0 by 0 form, right? So we will use
Yes,
the
ma'am.
L'Hopital rule. Then we will get f dash x by minus 2 not minus plus 2 root f of x, right? And for this we will get 1 by 2 root x, right? 2 will be cancelled out. Then we can directly put, so we will get f dash 9 by root over f of 9, and 1 over means this will be 2 into root over 9, right? So f dash 9 means 4 into 2 into 3 over 3. So 3 will be cancelled out. This will be 8. Is 8 the answer? Is it the answer?
I think yes, ma'am, it's correct.
Okay. So when we are getting some 0 by 0 or infinity by infinity, just if you have this type of question, first just put the value and check whether you are getting the indeterminate form or not. If you are getting this type of form, just simply apply L'Hopital rule. Okay?
Okay, ma'am.
Yeah. Okay. Okay, and in the beginning, someone of you was talking about some practice assignment of 7.
Yeah, ma'am.
Yeah.
Okay.
Yeah.
So I've just pasted you that screenshot. If you could please open that screenshot.
Yeah, sure. This one.
Yeah.
Okay.
So in here, I mean, the first and the third statement makes sense. Second is something that haven't been able to come up with an example of how this is true.
Okay. So for this, we have a simple example. Is it okay? If you take both the sequences A and Bn as minus n power n. Okay.
That
then
minus 1 to the power n, right? That is what you have said?
Yes.
Okay.
So this is not convergent, right? We know this type of sequence is divergent.
Correct. This is not convergent.
A and Bn will be minus 1 power 2n, which is the constant sequence 1, right? Right?
That is correct. This will always be 1. Yes. Oh,
So
okay.
this will be converges to 1. Okay. So we have some example says that both the sequences are not convergent, but the multiplication sequence is convergent. Okay.
Okay, ma'am. Ma'am, in the same thing, there is like another one, practice assignment 7. Let me just give the screenshot and just
sure.
help look at how it is actually working out.
Okay, sure. Just paste the screenshot in the chat box. I will see. Okay. Meanwhile, if any one of you have any doubt, you can just take the screenshot of your doubt and paste it in the chat box. I will pick your doubts. Okay.
So, ma'am, this one. So, yeah, I mean, looking at the problem, I was able to come up with an answer of 2, but there is like a outstanding question that I have. In this question, it says that this sequence A of n, this limit of an is e. That is what it says, right?
Yes.
Then it says limit of n tends to infinity ln of a of n type of expression. Okay. Like if had it been an a of n in isolation, then I would have said, oh, because n tends to infinity, I'm going to limit of a of n is tending to e. This ln expression, when it's coming, I'm getting totally confused. How am I saying that I'm going to take like that 2n plus 1 expression as a separate expression and say that, oh, I am going to apply n tends to infinity on that and say that, oh, this is
Okay. In this case, you can just take this as suppose n1. Okay.
Correct.
Then just replace it as n1 by n1 factorial to the power 1 over n1.
Agreed.
Okay.
My
So when
question is,
n is tending to infinity, this n1 is also tending to infinity, right?
that's right. That is right.
So we can use the limit, right? So this now become the same thing, right? Just
No,
Instead
but
of n, we are writing n1.
yeah, but here is my question, right?
Mm-hmm.
That I understood, and this is the exact way that I solved the problem.
Mm-hmm.
My question is that the first line does not talk about that ln of a of n is equal to tending to ln of e. That it does. It says that if I apply n tends to infinity on that an expression, then that isolated an expression tends to
Okay,
e.
okay. So that
How
the
is
thing is,
non?
you have a general form. I mean, if you have a continuous function fx, okay, then you continuous and function and limit basically exchangeable. I mean, we know that limit extending to a f of x equals to fx for a continuous function, right?
Ma'am, if
Yes.
you keenly observe this question, you can see that the both of the limits are subsequence of n by n factorial to the power 1 by n.
Yes.
Wait, come again.
Yes.
That's one more time. So it is.
Then this is if you can take this as some sequence, and suppose this is another sequence, so both the sequence are subsequence of this sequence an. So, and we know that if we have a convergent sequence, then all of the subsequences will be converging to same limit.
Yes, ma'am.
Okay, then we can follow this logic too. This is a very good logic.
Yeah, this statement actually I did not understand. Can you please help me just elaborate on that? Like that, how am I applying that?
I mean, how are you like? Which is
So
your
this
doubt?
statement,
I mean,
no, this statement that was made, right? That it is lying between, like it's a subsequence of a of n, this ln 2n plus 1. Can you like, is there a way to elaborate on this? Like I'm not
yeah. So
getting.
this is the subsequence of the sequence. Is it clear? I mean, we are taking the odd terms from the sequence.
Oh, no, ma'am, that is clear. See, how do I explain this? That is clear. What I'm saying is this in the line where you have written limit of x tends to a f of x is equal to f of a, you have written, right?
This is the definition of continuity, right?
This is a definition of continuity. So what you are saying is if my x
When
tends
we
to
have a continuous function, we can exchange the function and limit. I mean, we can take the limit inside. Did you get my point?
Okay.
Sorry.
Okay. Got it. Thank you. That is exactly what was the
The
question.
answer would be like limit n tends to infinity and one constant functions will be there. So 1 plus 1 equal to 2. I'm getting the answer. Is it right? Could you just?
Yes. So because we know that logarithmic function is a continuous function, right? So we can, because we know this, so we can take the limit inside. Okay. So we can write it as limit, then this function. Okay. So this will be e, right? So we have ln e plus again ln e, which is 1 plus 1 equals to 2.
Okay. So if the question is ever given, I mean, if it is ever given, then it will totally be assumed that if someone is asking me to apply this, then the function itself should be a continuous. If a question like this comes in, right?
Okay. But the thing is, it may be the function, I mean, may not be continuous. You may check. I mean, if in your exam or in your question, you will get some simple function, right? Exponential function or logarithmic function or any trigonometric function. So we already know that these functions are continuous, right? So you can just assume that you will get the continuous function, but okay, you should know the logic behind this step too, right?
Got it. But we cannot apply the same theory on a discontinuous function.
Yes,
That is
yes.
not like,
Yes.
okay, got it. Thank you, ma'am. This is exactly what I was wondering.
Yeah. Okay. So if you have a discontinuous function instead of the logarithmic function, then you cannot apply this. But because you have a continuous function, so you can exchange the limit and the function.
Yeah, perfect.
Ma'am, can you go to question number 4 of practice assignment and explain it?
Okay.
Three statements.
Madam, I just pasted a simple question so that that continues are differentiable related to one question.
Sure.
So can you open, madam? I have a simple doubt actually.
I mean, do you need to open the practice assignment or what?
No, I pasted
Oh,
in the
you
chat box.
pasted.
Yeah.
Okay. Yeah. Yeah, I
So
got you.
here I can see regarding to the figure 2, I understood the questions. I know that. That figure 1, I have some doubts. So what is the sharp edges? It's not differentiable. In the lecture, I understood, but how it's not differentiable, I don't understand.
Okay,
That
okay.
point.
So that means actually we have that point, right? I mean, if a function is differentiable at some point, that means we can draw a unique tangent line, right?
Yes.
So at 1, we cannot draw a unique tangent line. I mean, at 1, you can draw this line as a tangent, which touches the 1, right? The curve at the point 1, right?
Yes, yes.
One can draw this line as the tangent line, right?
So 2 tangents will come.
Yeah, and one can draw this tangent line too.
Okay, okay.
So there are so many lines which can be the tangent line. I mean, which can touches the curve at that point, right? But if we cannot find the tangent line as a unique line, then we cannot say that the function is differentiable. Okay.
Differentiable. Okay.
Yeah, yeah.
Okay, understood. Then it's not. Then the differential at any real number, madam. What is the meaning? I don't understand. So, if one is continuous and differentiability each real number.
Okay, that means it is differentiable in the whole domain. I mean, a real number means our x-axis is the real number, right? A set of all real number, right?
Yeah. X-axis is the domain.
But
yeah,
that is wrong answer, madam. Actually, in the
yeah.
so
This is wrong answer, no? Because at that point the function is not continuous, no?
Because it is breaking. It is not continuing.
Yeah. So because it is not continuous,
no, madam.
is not differentiable.
No,
It is
madam.
continuous, right?
Madam, I'm talking about your first figure, madam. They're asking for the F1 is continuous and differentiable but each real number. So that I'm asking actually.
No, first one is continuous. We can say.
Yeah, first one is continuous.
But not differentiable.
And differentiable at each real number means
no, it at each real number means in the whole domain, like at each point of the real number system.
Okay, which means
because
0 to
we
infinity.
have if is not differentiable at 1, that means we have an example, right? I mean, at the point 1, if is not differentiable, so we cannot say that if is differentiable at each real number, right?
Okay, understood, madam. Thank you.
Yeah, okay.
Arun, from where you have attached to this question?
It's from the activity questions only.
Okay.
Yeah, ma'am, I think yes. No, not in this question. I think Deepak has pasted a question to everyone. I think, I would be interested to go through that question, please.
Okay, this one. Yeah.
Yeah, this one.
This one is week 9. Week 9 graded assignment.
Oh, this is week 9.
Okay. Week 9 graded assignment we will not cover right now. This is your revision session. So let us just be focused about it.
Okay, thank you.
Ma'am, week 9 will not come.
Coming now. This kind of question now, when reading itself, we are getting fear, madam. So maybe our because reading itself, understanding itself will taking almost 15 minutes.
Yeah, because of the size.
No, it's also a standard question, not
that is
easy
okay.
one.
But in exam point of view, 1 hour now. So this kind of questions, we are maybe we are not
in
practice
the
question
exam
coming now.
in the exam you will not get this type of lengthy question. Don't worry.
Okay.
In the exam you will have simple question, just this type of sample question I just solved this type of sample question.
If it is this kind of question coming now, then one question only we need to complete, madam.
No. This type of question will not be in the exam, so don't worry about it. We will always, like, while creating the question, we always recheck whether we can solve it within some half an hour or not. So don't worry about the timing. You can solve it within the time.
Okay, madam. Okay, thank you.
Yeah.
So, ma'am, I'm sending one more question. So there is like a multiple choice. I'll just give like one more screenshot. That's that specific question number 9 that I want to solve. This is of assignment 7, practice assignment 7, not graded.
Okay, so this is the function and we have number 9.
So, correct, number 9 in that. I've sent the 2 screenshot because it's like the context is provided in the first screenshot.
Okay. So what is the doubt here?
So, how do we like set of correct options, right? That is what I was not able to come up with.
Okay, so then tangent of the function represents scheme A does not exist. Okay, so in the scheme A, that means a P1 function is a is a floor function, right? And we know for the floor function, limit doesn't exist at the integer points, right?
That is correct. That is correct.
So for P1, limit doesn't exist at the integer point. That means limit doesn't exist means it's not continuous and it's not differentiable. Okay.
That's right.
And from the ceiling function, again, in the same logic, limit doesn't exist and not continuous and differentiable at the integer points. Okay. And the P3 function, it is a simply straight line, right? So it will be continuous and differentiable everywhere.
Ma'am, what does it mean when you say integer points? Can you explain?
Integer point means plus minus 0, plus minus 1, plus minus 2, and so on. You know the integer points, right?
Okay.
So one is integer point, right? So the tangent of the function P1 is not differentiable at 1, right? Hence tangent doesn't exist at 1, right? So this is correct. Okay. The tangent to the point to the function P1t, which represents scheme A, doesn't exist at A for any natural number. So natural number is a subset of integer, right? So this is also correct, right?
No, but any natural number, as in like P1t is a floor function, right?
Yes.
So for any natural number means like, let's say for between 0 to 1.
Okay.
So at that point in
No.
time,
See, for any natural number means like at any natural number. I mean at 0, at 1, at 2. At any natural number, limit doesn't exist. That means not differentiable. That means tangent doesn't exist. So we will get this type of function at the integer or natural numbers, right? So we will get different limit, right? Yeah. So tangent doesn't exist. And for this P3, the P3 is a straight line, right? So it's everywhere continuous and everywhere its tangent exists, right?
Right.
So this is incorrect, right? And for P2, the tangent to the function P2, which represents the scheme, doesn't exist for any natural number. Similarly, this is again correct, right?
Yeah, ma'am. Thank you so much for clarifying.
Yeah. Okay. Is it clear?
So, ma'am, now can you go to practice assignment 7 again and explain question number 1 and 4?
Sure.
Actually, practice assignment questions are theoretical questions. If you explain all of this, then it will be good because the solution provided to us is not as good enough.
I explained the practice assignment question in the open session. You can go to the
in the middle I haven't present in all open sessions because of the assignment deadline.
Okay, so you can go to your YouTube, then just go to the live. Then if you want to also you have the recorded version of the solution. So you just check.
Yes, I have, but the explanation is not that much good.
Okay, so just let me know in which problem you are facing.
Question number 1 and 4.
Okay, so what is your doubt in question number 1?
Now first come to 4, then come to 1.
Okay.
In question number 4, explain me the question, all these 3 options. Statement 1, 2, 3.
Just the statement 2 I just explained right now. Just 2 problems before. This one, I just explained it. You was in the session or not?
We just covered it, Divya.
I just covered this one.
The previous one, which I have answered also. Okay. But question number 1, statement 1.
Okay.
Statement.
So in question number 1, what is the problem? I mean, let me know the specific problem, then I will just focus on your problem.
Okay, let me open my notebook.
Sure.
Ma'am,
Option 2,
actually
ma'am.
I have
5 and 7. Explain. Actually,
Yeah.
if you explain the entire question, it will be good.
Okay, so I will explain some options and you can just take the other option in, like, discuss the other option in similar way. So limit of the function as x tending to 0. So this is the point 0, right? So when x tending to 0 means we will consider the domain. So x tending to 0 means x is tending to 0 from this side or from this side, whatever. Then the function will be tending to 0 in this way, right? So the function is,
Yes, ma'am.
functional value is also 0, right? When x is tending to 0, the function is also tending to 0, right? From the positive side or from the negative side, right?
Right.
So this is the correct answer. Okay. So immediately these two will be wrong. Okay. So there is a unique tangent at the point x equals to pi, but not x equals to pi. Okay. So at x equals to pi, this is the function at x equals to pi, right? And this is the tangent. And at x equals to minus pi, this is the tangent. So we can see at both x equals to pi and minus pi, unique
Unique
tangent
tangent.
exists.
Not unique.
Why not unique?
Same tangent. Same line is touching both of the points.
No, not this. I mean, for this function at that point, this line is unique, right?
Yeah,
That is
line
what
is
we
unique.
mean. That is what we mean by unique tangent. That means I mean, unique tangent exists, means tangent exists. Okay, I mean the tangent line is unique. It may be the case that this, I mean, the x-axis is tangent for the curve at both the point, but the tangent line is unique, right?
Entire x-axis is correct.
Yes. Tangent line is unique. That is what we mean by this statement. Okay. Did you get my point?
Yes, I am getting.
Yeah, okay.
Madam, I pasted another problem similar to one. So,
Ma'am, the option 4 will be wrong and the fifth will be correct.
Yes.
And the last two?
Okay, so you just check this interval. I mean, minus 0.5 to 0 means in this interval. In this interval, the function is this, right? I mean, this portion is the function. So this is clearly monotonically decreasing, right? So this is the correct answer.
Yes.
Oh, okay.
Okay. Yeah. Yes.
Madam,
Ma'am, I have
simple
pasted
one
a
I just pasted
question.
in the chat box.
Okay. Yeah, I'm coming to the chat box. Wait.
In chat box, madam.
Okay. Yes.
So slope is 0. So for this one, so f is continuous on R, it's okay. They're correct. I understood. And its f is not differentiable at 0. So which means it is going only, madam, continuous only. No, y is not differentiable. Earlier you told if it is going in slope is 0, then there is also it is differentiable, right? Then for this condition,
But
why?
okay. I'm saying, actually here, this is the slope, right? I mean, if you just like draw the line which touches the curve at 0, this is the line, right? This is the unique line, right?
Yes.
And the slope is, I mean, the degree between the line and x-axis is 90 degrees, right? Then the
Tan 90 infinity it will come.
yeah. So this is not finite, right?
Okay.
I mean, this is basically equals to f inverse of that point.
Finite means does not exist, right? So
Yes. So this will be infinity, right? So if you just recall the definition, we need that f inverse s to be something finite limit, right?
okay.
Because it is infinite, so we will say this function is not differentiable at 0. Okay.
At 0. Okay. Understood. Thank you.
Oh, thank you so much. I need to lean you. Sorry for that.
Okay.
Ma'am, I have pasted a question. It's from graded assignment.
This
Please
one.
explain this step by step.
This one.
Yeah, yes, ma'am. And one thing I want to ask, is there any chances of getting these type of questions in exam, quiz 2?
No, this type of questions are lengthy, so you will not get this type of question. Actually, for this, I will just prefer you to go to the recording. I mean, if you have this type of question, now you just have to balance the function in such a way so that you can use the limit. Okay.
Okay.
So because see, I will give you the hint because you have this one, right?
Yeah.
So suppose you want to find the limit, then you can match this one with this formula, right?
Okay.
So you just have to use some 27 over n here, right? So
Okay,
you
right.
will again multiply 27 over n with and divide it with n. So okay.
Okay,
Similarly,
got it.
when you have this, you have to match it with this formula, right? So you just again balance this form as this, just multiply and divide it with 21 by n. Okay. Similarly,
Okay.
this, you try to apply this formula. So again, you
Okay,
have to
ma'am.
balance this in this way so that you can apply this.
Okay, ma'am. So here I just only have to manage all the formulas
Yes, right.
in the given
So
form.
whole these things are inside the exponential. Okay. So
Yeah.
again, we know that exponential function is continuous, so we can take the limit inside, right? And you just
Okay.
take this thing and manage this thing in such a way so that you can express the whole this whole thing in such a way so that you can apply the formulas. Okay.
Okay, ma'am. Got it. Got it.
Yeah.
Okay, thank you.
Excuse me, ma'am. Ma'am, I have some doubt in week 9. Can you solve? Week 9 में doubt है, ma'am.
Week 9. Okay, week 9 we will cover later. First, let us focus on week 7 and 8 because it's for your exam purpose, right? So this is the last revision session. So we will first focus on your
Ma'am,
week 7 and 8.
in
Yes.
quiz 2, the weightage of week 5 or 6 is greater, or week of 7 or 8 is greater?
Almost same. It's almost same. I mean, you will get almost similar type of weightage from each of the week.
I have a question. Can you hear me?
Yeah,
so,
sure.
Previously you have shared this root x cube, that question. Can you show that?
Which one? Root
Cube root x, which is infinity.
Is it in the chat box or?
Yeah, previously, before that question. Not previous one. So Arun was asking about why it is not differentiable at 0.
Okay, this one.
Oh, no. So
Not-
you're saying that this is tan 90 is
Okay,
infinity.
just this one. Yes.
So so this tan 90 is different minute. Infinity or undefined?
Okay, again we have ambiguity, but you can take it as undefined. Also, you can take it as infinity. I mean, both are correct. So in
Because
both the
1 by
cases,
0
it
is
is not.
undefined.
Yeah, 1 by 0 is undefined, but if we just follow the graph, I mean, we know the graph of tangent is like that. I mean, when x is going towards towards the point pi by 2, this graph will be going to the point infinity, right? So it's basically infinity. So sometimes we consider it as undefined. So both the things are correct. So in both the cases, anyways, this we will not consider the limit to be something finite, right? So we will consider the limit doesn't exist in both the cases. So both the things are correct. Okay.
Okay, got it. Thank you.
Okay. Any another?
And one more question. Previously, you solved this f of 2
In the chat
It's 0
box
by 0
or
form so that you got access. Yeah, chat box only. I got
okay.
lost connection. My connection is poor. So
Okay.
that one
Which
actually
one?
f of dash they've given, but shared by Manish, I think. Manish.
This one? Okay.
Yes. So this is one f of 2 they given. F of 2, f of x they are not given, right? That one I don't understand.
Yeah, actually we have to, like, when we are checking whether it is in 0 by 0 form or not, I mean indeterminate form or not, we will put the limit instead of x. Like this is the rule to check this type of thing, no? So we have to search the value when x is equals to 2.
F of x is not given in the question, right? Or
No, yeah, f of x is
we have
not
to
given in the question, but because we are we are going to apply the L'Hopital rule, so we will follow the L'Hopital rule, right? So that is what we just put 2 instead of x, then we will calculate whether it is in the form or not.
Ma'am,
Okay,
0 by
directly you're
infinity
talking.
form.
No, this is 0 by 0 form, no?
0 by 0 form.
Yeah, so we can apply the L'Hopital rule, right?
So we will have to derive.
Yes, we have.
Differentiate it in the form of u by v.
No. What is the L'Hopital rule? I mean, if you have limit extending to a sum f x by gx, okay, and if a by ga is in 0 by 0 or infinity by infinity form, then we use the L'Hopital rule, and the L'Hopital rule is simply f dash x by g dash h. Okay.
Oh.
So here 2 into f of x, 2 into 10, so 20 minus 20. 10x minus 20. Is it correct?
So 2 into 10 minus 2 into 10. So this will be 0, right?
Okay.
This is 0 by 0 form. So we can now derive it. So the derivative of this is a constant, right? So this will be as it is. And derivative of x will be 1. So we will get f of 2, right? And
Okay. Simply you are getting 2x. Okay. Got it.
By 1. Okay.
Okay.
Ma'am, I have doubt in activity 7.3 question
Very
number
simple.
9.
Yeah, it's very simple. Yeah. Which one?
Activity 7.3 question number 9.
Ma'am, are you from West Bengal?
Yes.
From Kolkata, na?
Yeah.
I am
Ma'am,
from
this
West
symbol.
Bengal also.
Okay.
Ma'am, I have doubt in this symbol. What is this symbol?
Okay.
Represents, ma'am?
You're asking about this symbol?
Yes, ma'am.
Okay, so this is basically this is called gamma of f, and this is basically the set of graph of x. Okay, this is graph of it. Okay, and this
What
is
will
this
this
symbol is
represents?
called, this is capital gamma. Okay, graph
What
of
is
f
this
is,
symbol represents, ma'am?
yeah, I'm just writing it. This is the set x comma fx. This belongs to a. Okay, gamma of f is the set x comma fx. Okay.
Then which of the options are correct?
Okay, so this cardinality will be same as the cardinality of a. Okay, because for each x belongs to a, we are taking this pair. Okay, and we know that for each point of the domain, we will find a particularly, a unique image for the point, right? So we will find this pair. This number of pair will be exactly same as the cardinality of a. Okay. So this is this option is correct. The cardinality of gamma x f will be same as the cardinality of a, and this is less or equals to the cardinality of a cross B. Okay, when we have the B as Singleton said, then we will get the exact same cardinality, or if not, then we will get a less something. Okay, because this gamma of F is always a subset of A cross B. Okay, so the cardinality of gamma of F will be less equals to cardinality of A cross B. Okay.
Okay, ma'am. I'm a bit out. What is the difference between f of x and gamma of f?
Huh?
What is the difference between f of x and gamma of f?
F of x is the functional value. This is the image, and gamma of f is a set. I mean, this is the set of this type of pair, x comma fx.
Okay.
Okay.
Okay, ma'am. Understood, ma'am. Ma'am, I have two more doubts in activity 7.4, question number 1 and question number 7.
Okay, so what is the doubt in question number 1?
समझ नहीं आया, ma'am.
I mean, did you try to solve the question?
Yes, ma'am.
Okay, so what is the doubt? I mean, which point you are not getting?
R to R is also defined in function. In natural number to real number is also defined in function. Then,
like
in
we
which
have
of the
5
cases a
function
function is not defined? Yes, ma'am.
Yes. So, no, they have said that which of the following represent a sequence. I mean, we know that when we are talking about a sequence is a particular type of function for which the domain is natural number. Okay.
Okay.
So when the domain is natural number, this function can define a sequence. So they have mentioned the domain for each of the function, right? So you can.
Okay.
Yeah. And
Question number 7, ma'am.
Question number 7.
That one. What is the answer now? What you explain natural numbers? So option number previous one, madam. So you explained it just now. Yeah.
This one.
So for this F2 is the answer, right?
F2 and F5.
F2, okay. Whatever natural numbers,
yeah.
So for because integer and real numbers, it will not have. Okay.
Yeah.
Only natural numbers. Yeah. Okay.
Yeah. Domain matters only.
Okay. Thank you.
Yeah. In the 7th problem, yeah. What is the problem in the 7th? I mean, what is your doubt? You have to calculate the limit. Okay.
Ma'am, we have to rationalize the equation.
Yeah.
I think.
Yes, right. You have to rationalize the equation. So, I mean, what you can do.
Okay, ma'am. Got it, ma'am.
Yeah, just multiply it with root over 2n plus 1 plus root over 2n. Okay, both sides.
Okay.
So, multiply
Thank
it
you,
with this thing and divide with it. Then you can calculate. Okay.
Okay.
Any other doubt?
8.1, question number 6.
What is the problem here?
ये ऑप्शंस फर्स्ट ऑप्शन ये प्रूव की कैसे हुआ वो समझ नहीं आया.
Okay, so you can write it as f of 1 into x plus y. Then you can take this outside. X plus y, f of 1, x, f of 1, y, f of 1. Then just take it inside.
समझ गया मैं.
Okay, so please, if you have problem in activity questions and practice assignment week 7 and 8, I will recommend you to go through the
madam, that I just checked actually up to week 7 only available, madam. Week 8 you not posted it.
Yes, right. Week 8 it's still pending. Yeah, we will post it. Yeah.
So when you are planned, madam? Actually tomorrow or so.
When is your quiz too?
Sunday, madam.
This Sunday, right?
Yes, yes.
Okay, okay. Then by tomorrow, we will post it. Okay.
Okay, thank you, madam.
Tomorrow or day after tomorrow, maximum maybe. Okay.
If you posting tomorrow, na, so we can. It will be helpful, madam.
Yeah, yeah.
And
We will try to do that.
one question: once you post it, how will we know that you have posted it? Do we get like that notification somewhere?
Maybe you are not getting the notification, right? So you can subscribe the channel, right? Then you will get the notification if some new
Yeah.
content is there.
Okay, and it will be called out, right? That maths week 8.
This should
reasons
be, yeah, this should be the case. Yeah.
Okay, all right.
Ma'am, mine issue is like more of a general thing. This 7 and 8 week has happened so many. It seems like so much things has happened so less time. My confidence in quiz 2 is like very low. I mean, for all the previous weeks, if you see the video and then you do that assignment, you still have some logic. But from 7 onwards, what has happened? The more you see the video, the more confusion gets. All I was relying on the past videos and all, but I mean, some issues regarding that.
Okay, the thing is, we for this type of problem, we have only one solution, that you have to practice more and more. I mean, we don't have any other solution. You have to just first learn the concept and practice more problem over the concept, and this is the only way to clear the doubts.
Okay.
Yeah.
Only thing is, ma'am, when for working professionals like us, if the concepts, if there is, still 6 weeks, the concepts were like very grounded. If you see the videos, you gain a good hold of concepts. Then you feel like,
Yeah,
but what
that's
happens
why
when
you
a
need
concept?
to join the live classes, so that you can
That is.
us and you can clear your doubts too. Also, in the revision session, I asked you, do you have any doubt regarding the concept? Then also I will recover the concept and all.
Yes,
So
ma'am. Live sessions are always good.
Live
Live
sessions are
interaction
good,
is the
yeah.
best interaction.
Yeah, so yeah, this is the best way you can do. Just watching the video is not sufficient to get a course. So attending the live session is really important, so that you can directly just interact with us and you can just solve your doubts.
Yeah.
But because of so much pressure, we always not.
Yeah, we can.
कितना करे वो then वो एक लेवल के बाद इंटिमिडेटिंग लग जाता है, डर बैठ जाता है ना कि यार ये होगा ही नहीं मेरे से, वो कॉन्सेप्ट प्ले बेसिक में, तो all that factors plays out.
No, I just want to say ki don't take it as something horrible. Just try to enjoy them. I mean, this concept are not that difficult. Always try to join the live session so that you can interact. It will boost your confidence actually. So and try to solve all the problems so that
Ma'am, one thing you can do for us, because the CT TA session and the maths TA session are crashing every Wednesday and Thursday. So
Wednesday and Thursday. Okay.
So can you reschedule the maths TA session in the morning or?
Okay. I will talk to my team about it. This is a serious problem. You should not get this type of thing. Yeah.
Because we have to choose one, because the same time.
Yes. That is correct. So can you just repeat Wednesday and?
In the normal time, the TA sessions are crashing. Maths TA session are crashing with CT TA session.
I mean, which day? Wednesday and?
Thursday.
Wednesday and Thursday. Okay.
Wednesday and Thursday.
Okay. I will talk to my team about it.
And ma'am, if I don't know if my suggestion works, I just have a small suggestion. From week 7 onwards, please bring back Nilesh sir or Madhavan sir.
Ma'am,
The way
I
they
have
teach is
two more
something else.
doubts.
No, we cannot do this type of thing. But if you are facing difficulty, then there are optional videos recording too, and always I will suggest you to join the live sessions. This is the best way to learn something. I mean, you can have any doubt anytime, so you can ask in your live sessions. This.
Okay.
Excuse me, ma'am. I have two more doubts, ma'am. Activity 8.3.
Yes.
Question number
Ma'am,
7, option A, first option. क्वेश्चन नंबर 7 ऑप्शन फर्स्ट भी तो सही है मैम, पर वो बाहर शो कर रहा है कि ऑप्शन फर्स्ट गलत है, जबकि ऑप्शन फर्स्ट भी तो सही है। यहाँ भी तो अपन लॉफ्टर रूल अप्लाई कर सकते हैं।
No. We cannot apply because I solved it in the last sessions too, but let me recall it again. So if we just put, we will get infinity by infinity, then we will apply L'Hopital rule, but after applying L'Hopital rule we will get this one, right? But even in this step we cannot calculate the limit, because when n is tending to x is tending to infinity, cos x can be anything between -1 to +1, so we cannot conclude anything about the specific limit when n is tending to infinity. So basically we cannot calculate the limit for this for this function using the L'Hopital rule. Okay.
Okay, ma'am. Question number 8.
Ma'am, the limit of the function is should be 0.
Wait, for which one?
The first one.
No. Why the limit is 0? How can you say it?
Suppose if I put if I divide x from the both side,
okay,
then it will come 1 by 1 plus sin x by x.
Yes.
Then I have to limit x tends to infinity, sin x by x is 1 by infinity is 0. So the limit would be 1. Oh.
The limit will be 1, right?
Oh, sorry, sir. I am thinking that is going to be.
Yeah. So the limit will be 1, but we cannot, we can evaluate the limit, but we cannot evaluate the limit using the L'Hopital rule, right? So L'Hopital rule will not give us a specific answer. So this option will be incorrect. Okay.
Okay, ma'am.
Yeah.
Ma'am, question number 8.
Okay. This one.
Yes, ma'am. Ma'am.
So for this question, you just apply the definition. Limit h tending to 0, h plus 9, sorry, f of minus f of 9 by h. Okay, then write it as f of h, f of 9 minus f of 9 by h. Okay, then take this f of 9 outside, then we will get h tending to 0, f of h minus 1 by h. Okay, because this derivative exists, so we have to consider that f of 0 equals to 1, then we will get the 0 by 0 form. Okay, so we will apply the L'Hopital rule and this limit will be f dash 0. Okay, so your f dash 9 will be basically f of 9 into f dash 0. Now we have the value for this too, so you can just put the value and then calculate. Okay.
Okay, ma'am. Thank you, ma'am.
Yeah, welcome. Okay, so if you have any doubt, you can ask. Otherwise, we will close the session.
It's already 10:40.
Yeah, so it's
Thanks, ma'am.
already...
Thanks.
Yeah, thank you, madam, for extending
Thank you, ma'am.
this much time.
Oh.
Thank you.
Thank you, ma'am.
Welcome.
Have a good day.
Yeah.
Good
Same
night.
too. Good night.